Mhm.
Sometimes because people log the presentations want to see it,
Mhm.
you leave it blank until the next time it's up.
Yeah,
Is that what we will do, or are we moving this up?
we're just moving up. We
Okay.
just forget this and then,
So the times
There-
are changing for
Yes.
as well. So I've just received a message from Pierre,
Mhm.
and says he's presenting in person.
Today,
Yes,
okay,
this is through the app,
okay,
and it says I have a oral presentation at 4:15.
yes,
Um, So so he knows that his talk has moved up at 4:15,
okay,
but he says it's in person.
okay, because we didn't receive any
He says he Well, I'd like to welcome you all to this talk session on General Fisheries and Water and Fisheries Management. It's time now, the room doesn't look like it's time, but we have to. Let's start this time. It's a break, folks get tea, yeah, so, wait a couple of minutes. Okay, whilst we are waiting, there are a few logistical things to mention. So we have one more show session, presentation in third presentation in the name of Lorraine Uma Monday. So that is cancelled. So we will have to move up the second, the third and the fourth presentation. That makes this session usual. Yeah. So that's it. And then several of the presentations are actually remote. So the first presentation will be the third and the fourth will also be Zoom. And then we have a second presentation by Mr. That's why. So those are the logistical things to mention. I think we have to start.
Okay. I think Luis, you can start sharing your screen.
So whilst he shares the screen, a bit more on the ground rules. We have 15 minutes for each presenter, and that includes question time. So your presenters hopefully can plan your time so you can deliver in about 10 minutes. Leave a time, some time for interactions. When you're going over time, I'll get up and I'll say at you, and that would be a way of saying please hurry up. And of course, when the time is absolutely up, I'll have to tell you to wrap it up. I hope we don't run into that situation. Sometimes happens. So we'll go ahead and start. Our first presentation in this session is by Lois Safo, presenting from Ghana on the natural imperative for African aquaculture species and system diversification.
Okay, I think you can start if you want to.
Okay. Hello, everyone. I'm gonna present on the species and system diversification in aquaculture, a case study in Ghana. So aquaculture has been promoted over the last 7 decades as a source of protein, animal protein shortage in Africa, So the first system that was introduced was earthen pond, and it later upgraded to concrete tanks. And then just last recent decade, cage system was introduced to aquaculture industry in Africa. So cage system has improved a lot in the aquaculture industry, and um, aquaculture development in Africa have been slowing, and there are three causes that cause that slow pace. So the first cause is subsistence. The second one is one size fits all paradigm of development, which is when an experiment of an aquaculture is being done in a certain location, it's being assumed that it being successful in that particular location, it will be successful at every location. And then the third cause is lack of encouragement of local innovation, which is there's no encouragement to try new species or system to help the aquaculture industry. So this graph is the domestic aquaculture production graph of Ghana. So looking from 2000 to 2006, we can see that there wasn't much production through that years, but starting from 2007 to 2023, you could see that there is a huge improvement. And that was when cage system was adapted and people tried to use it a lot, and then it contributed a lot to the aquaculture industry in Ghana. So I know that people will be asking themselves that what happened in 2019 and 2020. Okay, so there was a disease pandemic at most of the cage farms in Ghana in 2019, and then 2020 was when we were having the corona pandemic. So after those disease and then the pandemic, everything went back on track, and then it went very well. The production has been very, very productive. So the question is, why new systems or new species in the aquaculture firm? So African catfish and then now tilapia has been the only species known in aquaculture sector in Africa. So if we try to adapt new species, introduce new species, especially species that are declining from the wild, that will really help in production and at the same time increase profitability and then reduce the pressure at capture fisheries. So new systems like RAS, which is the recirculating system, and the agroponics and other new systems can also help to promote sustainability because it reduces or it discharges small amounts of effluent, so it is environmental friendly and it can promote sustainability. And at the same time, since cage system has contributed a lot, if these new systems such as the RAS, the agroponics is being introduced, of course, going to increase productivity at the same time increasing profitability, reducing the pressure on capture fisheries. And also introducing new species, especially the declining ones, can also promote conservation as well. So our first case study was done about recirculating catfish culture with hydroponics or agroponics. So this study, we tried to introduce a new system. We did it in a 4 cubic meter tank, a waste tank, at our backyard, connected to 1.5 square meter grow bed with gravels and soil as the medium, and then tomatoes are the plants. And then we stocked the tank with 150 catfish juveniles. And it was very successful within 6 months of cycle, and then we got 150 kg of catfish, 25 kg of tomatoes as the end results, which shows that this type of system can really contribute a lot. We even did this in a waste tank. So you imagine actually using the system in aquaculture, it will really contribute a lot in the aquaculture industry. So this is the tank we used for the steady and then the grow bed with the tomatoes. So this is the end result. This is the tomatoes that we harvested and then the catfish that we harvested. So our case 2 study, we try to introduce new native species, species like Coptodon descala, Coptodon ziri, Tilapia busumana. They are all tilapia, but different types of tilapia, which is not known in the aquaculture industry. So we collected these species from Lake Bosumtwi in the Ashanti region of Ghana, and then we tried to capture them and then culture them in a concrete aerated tanks. And at the first week, because they haven't been in such environments, we saw some mortalities, but after that week, they started feeling comfortable and then started even spawning, and their babies, they were all fed with manufactured feeds and commercial manufactured feeds. So they were doing well, and then even customers or consumers were giving good reviews that this type of tilapia is even much tastier than the ones in the aquaculture industry, the ones known in the aquaculture. These ones are even much tastier, which means this is really successful. If we try to introduce such species or even more species which is not known in aquaculture, we can help to help give out a lot of options of choices for consumers. And Coptodon descala has been found on the red list on IUCN, which means it's really declining from the wild, and Tilapia busumana too is declining from the wild as well. So aquaculture is the best way to conserve these species, to promote productivity and at the same time gaining profitability as well. So these are the fish that we cultured. The first one is Coptodon descala, second one Tilapia zili, and then the third one Tilapia busumana. So through our studies, we encountered some challenges that we think farmers who try to adapt these type of systems might face. And the first one is expensive energy cost, and then 2, unreliable energy supply, and then the third is lack of technical know-how. So it is really advisable or recommended that farmers should try to use solar energy as their source of energy, because the recirculating system, the aquaponics, it uses a lot of energy to pump water from the tank to the grow bed and then back to the tank. So it uses a lot of energy, and relying on energy, normal energy supply wouldn't help. So solar energy is the best way to help in this type of system. And then the lack of technical know-how is recommended and then advisable that there should be training and an education to farmers about these systems, the importance of it, and then the introduction of new species, how these species are declining from the system or the wild, that needs to be saved through aquaculture. And this will help in promoting sustainability and promoting conservation, at the same time increasing productivity, and then at the same time increasing profitability as well, and then decreasing or reducing the pressure at capital fisheries. Okay, thank you.
So we will have a few minutes for questions. Anybody has questions? Yes, sir.
I think maybe you need to come a little bit more here so we can understand here.
Hi, Luis. My name is Alex Morgenstern from Fraunhofer Institute for Solar Energy Systems in Freiburg. And on your last slide, you mentioned the very high energy consumption of the RAS system.
Yeah.
And it's interesting because, it's definitely an important point. We are participating at the moment in a project where in Ghana and Kenya, partners want to install also RAS systems, and we were asked to reduce or to provide the energy with the solar systems, and we've discussed with the partners, and nobody of the partners could definitely show us a schedule of the different systems which are not in operation all the time. That means the pumps for the aeration, then the pump for the circulation of the water, and the heating and other things. And it's not running all the time, so it's not running 7 days or 24 hours, 7 days, and not all over the year. But it's definitely a point where we see a very high potential for the reduction of the energy consumption. If last point you mentioned a lack of technical know-how and understanding, and I think this is definitely the point where which could be tackled, and the overall energy consumption could be reduced significantly when there's a deep knowledge and understanding of the system behavior.
Well, thank you for your comments. Full disclosure, Lois is my student, so we connect with you after this.
Yeah.
So in the interest of time, we'll go on to the next presentation, but we have a wrap-up section at the end, so we can visit some questions later.
Okay.
So our next presenter, Lois, will have to disconnect, right?
Yes.
Yes, our next presenter is Nusrat. Nusrat is here in person. Thank you for being our only in person. And she's going to present on the effect of aquaculture techniques on household.
Yes.
Will be
Some point there, you point to the laptop. For the slide. Like this, right? Yeah, you don't, just in general direction.
Okay. Hello, everyone. So my name is Nusra. I come from Leibniz University, Hanover. I'm doing my PhD over there. And today's topic of my presentation is effects of improved pond aquaculture techniques on homestead, on household well-being, a case study from rural Bangladesh, from where I'm originally from. Okay, so this is the outline that I'm going to follow throughout my presentation. So first, let me begin with the introduction. Bangladesh actually ranks world's 5th largest inland aquaculture producer, and 57% of the national annual fish production actually comes from this aquaculture. And 80% of this aquaculture production comes from inland ponds. 20% of the rural population of Bangladesh have at least one operating pond, which is within or very near to the boundary of the household. So these are called homestead ponds, which are used mostly for household chores. And there is not much formal fish production happening there, but there are some fish anyways that irregularly comes through runoff water during the monsoon season. And it contains mostly carps and very limited small indigenous species. So small indigenous species are basically species which are very small in size, approximately like less than 25 centimeters. These are actually, studies show that these are excellent source of essential micronutrients, and these are mostly available in rivers and open water sources. But the problem is SIS diversity is actually declining due to environmental degradation and overexploitation. Hence, integration of SIS with CAR in the polyculture system is being promoted. But the problem lies that SIS seeds, these are not available in the market that often. So let's get into some nutrition situation of Bangladesh. So Bangladesh has 24% under 5 children who are still stunted, 12% of women who belong to 15 to 49 years of age are underweight, and there is very limited intake of vitamin A, iron, and zinc. So SIS, the small indigenous species, these are very rich in vitamins and minerals, especially because these are consumed in their entirety, including the bones and the heads and eyes. So the entire nutrient are intact. And it also provides 25% of recommended daily micronutrient intake